Adding formats is similar to adding labels. Recall that they alter the appearance of variable values. Here is the general form of the format statement. You start with the SAS keyword format, then you enter the name of a variable whose values you want to format, followed by the format you want to apply to the values. You may format multiple variables in a single format statement, and there are two main types of formats you can use in your SAS programs: SAS formats and user-defined formats. SAS formats are predefined formats that are built into your SAS software. You've already seen a few examples of SAS formats, like MMDDYY10 and $7. All SAS formats use the same form, as shown here. As you should know by now, a $sign indicates a character format, which precedes the name of the format. Then you specify the total format width, including decimal places and special characters. The period is a required delimiter that must be included anytime you reference a format. Finally, you specify the number of decimal places in numeric formats. Here's a table of the general form of a few commonly used SAS formats for you to look over. This table shows you several specific SAS formats and their effect on the way stored values are displayed. If you don't specify a format width that is large enough to accommodate a numeric value, the displayed value is automatically adjusted to fit into the width. Character values are truncated if they don't fit into the width. In the first example, you can see that the stored value overweight is displayed as over because the assigned format only has a width of 4. The other values shown here are numeric values. You can see that these values are rounded off instead of being simply truncated. SAS formats are not the only way you can change the appearance of values in your reports. SAS will also let you create your own user-defined formats. For example, here is a partial list report from a dataset containing information about mosquito traps in the North Texas region. Suppose you want your report to display a descriptive name for the type of mosquito trap instead of the number code for that type. Or, instead of displaying the raw count of mosquitoes caught, you want your report to display what quartile of all mosquitoes caught this particular trap accounts for. There are no built-in SAS formats to accomplish either of those tasks. However, you can easily do both with user-defined formats. Like SAS formats, user-defined formats can be applied in either a data or PROC step. Before we can assign user-defined formats in a data or PROC step, we must first create the formats using the format procedure. Then, in a completely separate data or PROC step, you will assign the format you created. It's extremely important that you understand the distinction between creating a format and assigning a format. Here is the syntax for a generic PROC format step. In a basic PROC format step, the PROC format statement consists of only the words PROC and format. The value statement is where you will actually define the format. First, you specify a format name. Then you specify how you want the values to be displayed. Now let's learn some rules for format names. First of all, some of the rules vary depending on whether you're creating a format for a character variable or a numeric variable. For either type of variable, a format name may have up to 32 characters. The name of a format that will be applied to a character variable must begin with a $sign, and the second character must be a letter or underscore. The name of a format that will be applied to a numeric variable must begin with a letter or an underscore. A format name cannot end in a number. All remaining characters in formats for either variable type can include letters, numbers, or underscores. A user-defined format name cannot be the same as an existing SAS format name. Also, notice that a format name does not end with a period in the value statement. Later, when you apply the format, you'll type the period. Now let's go over how to specify the way you want your values to appear when the format is applied. In the value statement, you specify one or more expressions called the value range set. Each value range set has 3 parts. First is the value or range of values, which refers to one or more values as they're stored in the input data set. For example, the character value DL or the numeric value 1. The second part is a single equal sign. And finally, you type the formatted value you want SAS to display after you apply the format. For example, Dallas County instead of DL, or light trap instead of number 1. You can specify the value or range of values in several different ways: as an individual value, as a range of values, or as a list of individual values. In each set of examples shown here, the top example has character values and the bottom example has numeric values. When you specify the value or range, you must enclose character values in quotation marks. The character values you specify must match the case of the values stored in the data. You do not enclose numeric values in quotation marks. When referencing a range of values, a hyphen separates the values that mark the beginning and end of the range. When you specify a range of character values, be careful not to enclose the entire range in quotation marks. If you do, SAS assumes that all of the characters, including the hyphens, are part of a single character value. In a list, commas separate the individual values. The formatted value is always a character string. It doesn't matter whether the format is being applied to a character value or a numeric value. The character string can consist of any type of character. Usually, each formatted value is enclosed in quotation marks as shown here. However, SAS does not require the quotation marks for the formatted value. When you specify a value or range, you can also use the keyword other to identify values that do not match any other value or range. If you don't include other, then SAS applies the formats only to the values that match the values or ranges that you've specified. All other values are displayed as they are stored in the dataset. In this example, any value in the dataset that you didn't specify in the PROC format step will be displayed as miscoded. Finally, you can only define one format per value statement, but you can write multiple value statements in a single PROC format step. Watch this demonstration of creating and applying formats in your SAS programs. Your first step is to create your user-defined format in a PROC format step. In this PROC format step, you're creating a format called gender and a format called standard01_. If you apply the format called gender to any variable in your dataset, female will be displayed in reports wherever the value for that variable is 1, and male will be displayed in reports wherever the value for that variable is 2. Likewise, if you apply the format called standard01_ to any variable in your dataset, no will be displayed in reports wherever the value for that variable is 0, and yes will be displayed in reports wherever the value for that variable is 1. Not only is it okay to give the format the same name as the variable name you want to apply it to, for instance gender and gender, but you may find that doing so makes writing your code a little easier. However, you could have just as easily named this format sex, x1, or tomatoes. SAS doesn't care what you name it as long as you follow the naming rules. Further, just because you name this format gender doesn't mean you can't apply it to other variables. When you type the word gender later in this program, SAS will know whether you're referring to the variable name gender or the format name gender, because when you refer to the format name, you will follow it with a period. This PROC format step also illustrates another best practice that you should know about. There's no need to create multiple user-defined formats for multiple variables that identically format the values. For example, here you create a format called standard01, yet there's no actual variable called standard01. This is because you have several variables in your dataset that use the values 0 and 1 to represent the responses no and yes. Rather than creating a unique format for each of those variables, you can create one format that displays zeros and ones as no's and yeses and assign it to all of the appropriate variables. If this doesn't quite make sense now, hopefully it will soon. This is probably a good time to discuss some variable value conventions. While you're certainly under no obligation to abide by these conventions, doing so will make your life much easier. First of all, a 0 is usually used to represent no or some other type of negation. It's often dichotomous. For example, have you ever been told by your doctor that you have cardiovascular disease? Yes or no. But it doesn't have to be dichotomous. For example, smoking status is often categorized as never, former, or current smoker. Now let's submit the PROC format step. When you run the format procedure correctly, the log tells you that the formats have been output, or created. However, they haven't actually been assigned to any variables yet. So if you PROC print the hospital data now, the display won't look any different than it did before you ran the PROC format step. If you want to assign a format to a variable, you can do this in either a PROC step or a data step. First, you will learn how to assign a format to a variable in a PROC step, using PROC print as an example. Here you type the print procedure as you normally would, except that we add a format statement. You then enter the name of the variable you want to format, then you type the name of the format we want to assign to that variable, followed by a period. Remember, SAS knows which is the variable and which is the format because the format name is always followed by a period. Also notice that you do not use a period at the end of the format name when you are creating the format in the PROC format step, but you do use the period at the end of the format name when you apply the format. Now your report has male and female listed under gender instead of ones and twos, and the variable check1 shows us yeses and nos instead of zeros and ones. However, because you only assign the formats in a PROC step, the formats gender and standard 01 are not associated with the variables gender and check1 in the dataset. As you can see in the results of the contents procedure, the formats are not shown for check1 or gender under variable attributes. And if we run proc print again without the format statement, the formats are no longer displayed. If you want the formats to remain assigned to the variables, we must assign them using a format statement in a data step. Here you add a format statement in a data step, creating a new SAS data set called hospital 3. And now the format standard 01 is associated with the variable check1, and the format gender is associated with the variable gender in the descriptor portion of the dataset. And when you run proc print again, even without the format statement, the formats are displayed. We will now have a quick tangent. I want to take a moment to demonstrate an idea that we have spoken about previously. First, I want you to quickly make a silly little fake dataset with a character variable representing a Likert scale type variable. Next, you will run the means procedure on the fake dataset you just created and tell SAS you want the mean of the variable called Likert by typing Likert in the var statement. As you can see, you get an error because you cannot get the mean of letters or words. In the hospital survey data, survey participants were asked about the cleanliness of the hospital and gave their response on a Likert scale. Each response level has a numeric value associated with it. For example, excellent is equal to 5 and poor is equal to 1. Responses to this question were recorded as the variable clean. Now try proc means again using the hospital survey data, and this time tell SAS that you want the mean of the variable called clean by typing clean in the var statement. SAS tells you that there were 100 observations for the variable clean. The mean value of those 100 observations is 3.01, which tells you that the average response to the question was roughly 3, or no opinion. However, this does not necessarily mean that 3 was the most common response. SAS then tells you that the standard deviation, a measure of the spread of values around the mean, was 1.34. And finally that the minimum observed value was 1, and the maximum observed value was 5. You now have a better idea of why you should apply formats to numeric values instead of creating datasets with character values. Now, let's close SAS, open it again, and rerun the print procedure with the format statement like we did above. Now you see an error in your log that tells you SAS cannot find the formats you're trying to assign. Just like SAS datasets were deleted at the end of a session unless we permanently stored them in a SAS library, formats are deleted at the end of a session unless we permanently store them in a SAS library. To do that, you just run the format procedure exactly the way we did it earlier, except that you add the library equals option to the proc statement. Some people like to create a library just for their formats. Others prefer to store formats in the same library as the data they are using the formats with, as shown here. Neither is right or wrong, just a matter of preference. However, there is still one more step before you can actually use the formats that you just stored. You must tell SAS to go get the formats out of storage so that you can apply them. You do this with the global statement options format search, the equal sign, and the name of the library containing the formats you want to use typed inside of parentheses. Now you have permanently stored your formats in the library in TRHD, and you have associated those formats with the variables gender and check1 in the SAS dataset called hospital 3. Warning: now that you've permanently associated formats with the data in hospital 3, you will not be able to use or open hospital 3 without first using the options format search statement each time you start a new session. This also applies to anyone else who tries to use hospital 3. Therefore, if you send the data to someone else, you must also send them the formats file. Without it, the data will be useless to them. Now let's look at some slightly more advanced uses of formats. Let's say that showing the exact value for everyone's income is not particularly meaningful for your current purposes. Often it won't be. You would rather break their income into categories and display these instead. But how do you decide cutoffs for these categories? Well, ideally, cutoffs for categories are chosen based on some value that is relevant and meaningful in the real world. In other words, based on good science. However, there are times when this information is not available, and in its absence, you need to create categories using some other method. One such method is a data-driven approach using quantiles, which is a general term for taking points at some defined regular interval. When you have 4 quantiles, they are called quartiles. Quartile cut points are commonly used by researchers when no scientifically meaningful cut point exists, or when they're just too lazy to go look for a scientifically meaningful cut point. To find quartiles of income in your data, you will use the univariate procedure. You do this by typing the keywords PROC univariate, specifying the SAS dataset you want to use, and then specifying the variables of interest using a var statement. The univariate procedure produces quite a bit of output, most of which you will not use in this lesson. However, you should inspect the table titled Quantiles. Every value from the minimum value up to the 25th percentile is the first quartile. Every value from the 25th percentile up to the 50th percentile, or median, is in the second quartile. Every value from the 50th percentile up to the 75th percentile is in the third quartile, and every value from the 75th percentile up to the maximum value is in the fourth quartile. Minimum and maximum values are shown here and here. Values for the 25th, 50th, and 75th percentile are shown here. You will now create a permanent format called income and store it in the library in TRHD, just as you did with the previous formats. However, this time, instead of telling SAS to format discrete values such as 0, 1, 2, etc., you will tell SAS that you want to format a range of values. So here you are telling SAS to format any value that falls within the lowest non-missing value, up to but not including 31,602.5 as first quartile. Before moving on, I want to point out a couple of things here. First, you don't have to use the word low to represent the minimum value here. You could use 0, and in this case you could have even used 15,039 and gotten the same result. However, using the keyword low is a good practice for formatting ranges of numeric values. First of all, it's easy, and second of all, you are sure to capture the lowest non-missing value. I keep saying non-missing because ordinarily SAS considers a missing value to be of lower value than any number. In this dataset there is no missingness, but remember this fact, it will be extremely important in the future. Next, I want to point out that the hyphen represents the word to in this context. In other words, it tells SAS that we are describing a range of values. Finally, I want to explain why I include the less than sign. To do that, I'm going to use another data set as an example. Here you are creating a hypothetical data set with 20 values for age, and a format called age that corresponds to the age categories of interest. When you print the data with the format, here's what you get. And because all of the ages in the data are integer values, this works just fine. Range 2 is the exact same data set as range 1, but the ages are more specific and carried out to one decimal place. Look at observation 12. Because 29.7 falls between 29 and 30, SAS can't format this value. Now let's make a new format using the less than sign. Now you're telling SAS to display less than 25 for every value from the lowest non-missing value up to every value less than exactly 25. This even includes 24.9999999. And we are telling SAS to display 25 to less than 30 for every value from 25 exactly up to any value less than exactly 30. This includes 29.99999. And as you can see, you now have no cracks in your coverage. Now getting back to the hospital survey data, because all values for income were integer values, adding the less than signs in your format ranges makes no difference. However, it's still a good habit to get into, and I highly recommend it. Let's run this data and print it one final time. And let's add one last new statement to the PROC print procedure. When you include an ID statement in PROC print, the variable you list is displayed in the first column of your list report, replacing the OBS column that SAS usually displays in the first column. If you list a variable in the ID statement, do not list it in the var statement. If you do, it will appear twice in the report. And there we have it. ID is in the first column, values for gender and check-in process are properly formatted, and variable labels are displayed for date of admission and check-in process. This concludes the video on using formats in SAS. At this point, you should be pretty comfortable with getting data into SAS and displaying that data in several different ways, including adding labels and formats. You should also now be able to find some basic descriptive statistics about numeric variables in your data. You are well on your way to becoming a proficient SAS programmer.